And it's just,
Okay. This is the last thing we need to learn, and this has to do with the part in the calculator that says Geomet PDF and Geomet PDF. So what you need to do today, my hope is when you walk out, you will know the difference between binomial and geometric. And the whole key is the word that I underlined twice up there. So I think that there was on the worksheet, there was what's the probability until you get the first something. And that is not binomial because it's not a fixed number of trials. It's until you get a success. And that's what geometric is. Okay, so you're hunting for that word first in the problems for geometric distribution. Return to the park ranger and his trees. Now he wants to find the probability that he will find the first disease tree on the fifth trial. Okay. So requirements for a geometric distribution. Those are very similar to binomial, except the first business. Okay, so it still has to be success or failure. You're used to that. In this case, it's infected or not infected. So that's the context for this particular problem. It still has to be independent. And do you guys remember in the original problem, we said there was no pattern to the infections? Okay. It still needs to be a consistent probability. And does anybody remember what it was for the infected tree? Nice. Okay. And then the last thing is not, so this would say, if you were in binomial land, this would say fixed number of trials. And if you're in geometric land, this would say first success. And in our problem, they're saying on the fifth trial, so x equals 5. Okay, so again, it's really not that bad. You have to hunt for that first, the word first in the problem, and then you'll know that you're living in geometric, not binomial. Okay. We already did this type of problem in chapter 5. So this was, do you guys remember the problem with me stopping at the red light in front of the high school? Okay, that's this. So, but we're going to write it with our random variable notation, which is what's the probability that x equals 5? In this case, that would be the first success on the fifth trial. So what that means is he walks up to a tree, it's not infected. He walks up to a tree, it's not infected. He walks up to a tree, it's not infected. He walks up to a tree, it's not infected. He walks up to a tree and it's infected. Okay, so what's the probability of that scenario? And that would be not infected 4 times, infected 1 time. And I know I don't need the 1 exponent, but I'm putting that there for a reason. So you can see. So not infected, not infected, not infected, not infected, infected. And we already did this in chapter 5. So this really should not be news. However, do you guys trust my I did the math before you got here? Okay. However, there is a spot in your calculator for us to do this with our stats notation. And so we're going to get the calculator out, and it's called Geomet PDF. Okay, so everybody, once you get this written, find Geomet PDF in your calculator. It's right by Bino. Which is not there. So I went second bars and I scrolled up because I'm lazy instead of scrolling down. And the geometric ones are the bottom two. Okay, so let's look at the menu. What is Geomet PDF wanting? How many things does it need? Two. How many things does Binome PDF need? 3. What's missing? Fixed number of trials. Exactly. This is not a fixed number of trials anymore, so you don't have that entry. I really want you guys to see that. Also, if you're stuck on a test and you're like, I don't know if it's Bino or geometric, did they give you 3 numbers or did they give you 2 numbers? Like, use that kind of common sense too to kind of help you shape that decision. Okay, so in our problem, we have the probability is 0.16 and first success on the 5th trial. And label that P and X. Any questions about what I did there? So first, I decided it was geometric because it had the word first in it. And the problem only gave me 2 numbers instead of 3. I went to PDF. And why did I do PDF and not CDF? Because it's equal. Okay, what do you think we're going to do next? Okay. All right, so let me move this so you guys can set up your notebook for the CDF part. Okay. On these 3 problems, I'm going to ask you to do 2 things in your mind. I'm going to ask you to take the words and translate it to an inequality. So which alligator is it? Do you know what I'm talking about? Okay, less than or equal to, greater than or equal to. Then I'm going to ask you to flip back in your notebook to the 6.3b note and see how you did it for binomial, because geometric follows the same rule. Okay, do you know what I'm talking about? What the complement of what and whatever. Okay. So the first thing we're going to do is figure out the inequality for each of that. Find the probability that you'll find the first disease tree on or before the fifth trial. On or before. What inequality symbol is that? Less than or equal to. Okay, so you have probability x is less than or equal to 5. Okay, and don't do anything with that right now. Just leave it. Okay, after. What inequality is that? Greater than. Great. Fifth or after? Greater than or equal to. Okay, now I'm going to give you 5 minutes, really. What I'm going to do is I want you to flip back to your 6.3b notes, match up the inequality symbol with what you did for binomial, and instead do that for geometric. So you're going to put geomet CDF in these, not binomial CDF. So wherever there's binomial CDF, you're going to replace it with geomet CDF, and then do it in the calculator. They're all CDF. Wherever it says binom CDF, replace it with geomet CDF. But you have to follow the same thing with the complements, so you have to be careful about those. On the side over by the calculators, it's like hanging down over there. Definitely do.
One minus one, or sorry, one minus nothing minus one.
Yeah.
But there's no grading.
Oh crap. 6.3a. It's 6.3a. I'm really special. It's 6.3a at the very end. There's all 4 different ones. And which I would suggest, by the way, put a big star next to that and put that on your note card. The very end of the 6.3a notes where it has all of the 4 inequality symbols. Did you guys find it? Okay. It's like 8 or less, more than 8.
Yeah.
Okay. I'm sorry, you guys. I don't know. Special lady. Real special. Not the same thing. Everything else.
Everything.
Exactly.
No, say everything else. Everything. Everything.
That was good.
No. I agree. Look, I was the one right and then one on. You know.
So we're gonna go to, as we said, you know, it was a changing greater and a place.
Now we're gonna.
Now, so instead of Yep. Perfect.
True.
The whole thing, right, it's freaking beautiful. It's horrible. Didn't even need, I could have slept in.
Yeah, I know a little bit, but I realize. I'm not ready yet.
Do not look at the screen until you are ready.
Yeah.
How did we do? Wait, you say? Yeah. Waiting. Oh, the beauty? Yes. No, it's okay. I just excited. Oh, yeah, that's right. The floor comes out of nowhere, it feels like, because we didn't do. Because you have to think, this is everything else except for the floor. Yeah. Oh, how did you make it? You guys are gonna be in college like 2 years from now and be like, everything is.
Bring with you.
Yeah, you have to, yeah.
Gotta get him. Don't bet, we've done a lot of that. I'm already now, but that's on chemistry, you have to like really remind like this too. Well, I love my kids.
Okay, now, I'm gonna give you another second while I'm talking here, just to get yourself situated. We're gonna talk about shape, center, and spread. So I need you to do 2 things. First, you're going to observe me do the Bryce Minty like genius. I have to tell you, this was not Mrs. Talbot's genius. Full disclosure, I did not come up with how freaking smart people are, which makes me really excited for humanity. But anyway, I also need you to get out your blue or your math 3 is blue sheet. Math is stats is the yellow sheet. Get out your yellow sheet and find the formulas for geometric distributions.
Yeah.
Yeah, that one's a good one too, but. Hey guys, so set up that little bit right there underneath your PDF. Sorry. Oh, I thought I was going to that. I got on the phone and I was like, this is probably like, it's not really that cold. And then I was like, no, I have to bring down jackets, blah, blah, and then I get here. What do I listen to that? Yes, but now I'm hot. No, but it's okay, but then you're more. Exactly. What if it was? I have all the layers. Yeah. Okay, I also just like this lesson, so I think it just making me happy. Okay, so you guys watch the genius of a student that was not me. Okay. And I've just told him, I was like, I'm gonna steal that for the rest of my life. Thank you very much. Okay, so I want to talk about the shape of a geometric. I would like you to notice how tiny the spot is that I left there. The really great news is geometrics are all the same shape. You don't even have to think about it. You don't have to prove normal. You don't have to like do a bunch of work. But I do want to show you the shape on the calculator. So I'm going to show you what Bryce did. Just so smart, I can't even. Okay, so in this particular problem, it was 5 trials, right? So I'm going to put all of my outcomes in L1, 0 or 1 to 5. Does that make sense? So all the possibilities. Okay, and then up here in the top of L2, I'm never going to ask you to do this, by the way. Never. I'm never going to ask you to do this. I'm going to go second vars, geomet PDF, and I'm going to put 0.16, but instead of the X value of 5, I'm going to replace it with L1. That's going to take that number and plug it in each one of those spots. And then hit enter. So you don't have to do it. Don't have to do it. I did give you it. I have my next one. Should I have done it to you?
No, I wasn't.
Oh.
Come on, John. Come on, John. Turtle cotton wool plastic. Yeah, that's a big thing.
Hey, what happened?
Us.
What happened? Oh. Okay, so here's my question. What's the shape? Right skewed. They're all right skewed. Every single one. You don't need to actually think about that ever again. What I do like to think about is I'm a math teacher at heart, right? So I like to think about things like this in terms of math class, out of just drawing in your prior knowledge from math 1, 2, and 3. Do you remember what a geometric sequence is? Okay. Okay. Yeah. A geometric sequence is a sequence that is formed by repeated multiplication of the same number. Okay, so times 2, times 2, times 2, times 2. And remember, it made an exponential curve. Okay, now, because we are multiplying by a probability, which is less than 1, means that this is exponential decay, which means that your number is going to get smaller every time, which means that the tail has to be to the right, which means that it has to be right skewed. Because they're getting smaller as you go. So it's, the tail is this way. That's how I want to tie it back into your prior knowledge. You're multiplying by a decimal every time. Going to get smaller every time, which means it's going to make that tail. Anyway,
I agree.
so you don't need to ever do the geomets in your list like, people do. Okay. Now, can you guys find the formulas for these and put them in the spots? Did you find them? Yellow sheet. Yellow sheet. The one that says geometric in bold. Find it in the box before you just write it down. Okay. Notice what letter is missing from the geometric formulas? N. There's no fixed number of trials anymore. The only number you've got is P. Okay, now let's talk about why 1 over P makes sense. Mrs. Talbot's really a big fan of collecting dumb stuff out of cereal box. Okay, let's pretend that she wants to get the Count Chocula figurine.
Oh.
You know who Count Chocula is? Okay, and let's just say that there's 5 different figurines. How many times would I expect? How many different boxes of cereal would I have to expect to buy to get the Count Chocula? 5, which is 1 over 1/5. Does that make sense? So the probability is 1 out of 5. Keep, change, flip. Expected value is 5. You guys cannot forget your keep, change, flip from math 3. Okay, so in our problem, guys, shh. In our problem, we'll do 1 over 0.16, which is 6.25. You guys okay with me, already having done that calculator beforehand? A couple of things I want to point out. First is that make sure that when you write this, it's very clear that the square root is only over the top. Do not put the square root over the whole thing. Trust me, that was one of the common mistakes I put in the multiple choice. So make sure that the notes are clear enough. I mean, you're gonna have your yellow sheet, so you can look at the type one too. But just be really careful about, like, when you're doing this in the calculator, like arrow out and then do divide by and then do 0.16. You know what I'm talking about? You gotta arrow yourself out of the square root. Okay. Second thing, when you're interpreting this, you need to make sure to use the word first. These are geometric. So this is the amount of time you expect to find the first disease treatment. So on average, you expect to find your first disease stream after 6.25 treatment. You have to use that word first in your interpretation because that's what these are asking, that they're geometric. So don't forget, don't just use the general one. You have to say first. All right. Flip your notebook if you're at the same spot as me. Yeah. Well, it's an example, but I spread it out. I did this is what I have, but I spread it out. What, is it huge or tiny? Oh, very small. Yeah, yeah. I don't know. I spread it out. Okay. So what I want to do is, I want to do a whole different context than the trees. Just start it over from scratch and review it. And then we're done with chapter 6. Save the name. 13. It is the 13th.
This Friday.
What is, did I do something wrong? Did I date something wrong?
No, this Courtney's called. Washington?
Yeah.
Yeah, it's for that, and it's maybe Saturday.
It sounds like to me that somebody did not update the calendar from last year.
Anyway, we have one day.
Yeah, I thought it was Saturday for Washington.
Okay, how about we do we do, rolling dice first before you worry about that? You can't see Callie, oh. You can't see, oh.
It's just James Day, it's not.
Oh,
But you know, like. It's like your fault, I don't think.
Look at this.
You good?
all right, guys. Shh. Sorry, I wanted to hear what that was, but I gotta move on. Okay, suppose you roll a pair of fair six-sided dice until you get doubles. Okay, shh, please listen. Your first thing that you're gonna say as a student is, Mrs. Talbot, you said that the problem was gonna say first in it. Okay, this problem does say first in it. It just doesn't say the word first. Okay, what's the other word that means first? Until. Okay, and what you could say is until you get your first doubles, if that helped you. Okay, show that it's geometric. There's four things, success or failure. So doubles or not doubles. Success or failure. Do you guys know what I mean by doubles? Like 1 and 1 or 2 and 2. Okay, just checking. I don't know. I thought everyone knew about cards and that wasn't okay. Okay. Every time you roll a pair of dice, are those independent events? Yes. Is there a consistent probability of getting doubles? Okay, and please pause. You might not know what that is, but you do. Don't flip your notebook. I don't have time. But I'm going to show you this. Okay, how many total options are here? 36. And how many of them are doubles? Yeah, so this one, this one, this one, this one, this one, and this one, right? Okay, so 6 out of 36. Okay, normally in this class, I work in decimals, but the decimal for 1/6 is horrible, so I'm going to use the fraction. And then we're looking for something when it happens the first time, and we're looking for the first doubles. Okay, so geometric, great. Find and interpret the probability that the first time you get doubles is the third roll. Okay, so probability T equals 3. Okay, PDF or CDF? PDF. Yep. Do you need me to do it in the calculator or you got it? Okay. All right, but we do need to write the sentence. It's important. So there is an 11.6% probability that you will get your first doubles on the third roll. So third grade conclusion sentence, not a big deal. Just make sure that because it's geometric, you're saying first. You're not saying there's an 11.6% probability that you will get doubles. Don't say that. We already figured out the probability of getting doubles. That was 1/6. Okay. Less than. Okay, what do I do for less than? This is the one I left out because look at me. So it's close. So less than CDF or PDF? CDF. However, it's not exactly the same. Less than 3 is the same thing as less than or equal to 2. Let me say that again. Less than 3 is the same thing as less than or equal to 2. And CDF is less than or equal to. Less than 3 is the same thing as less than or equal to 2. Because they have to be whole numbers. If you guys are wondering where that 4 came from in the last one, that's where it came from. Okay, last thing. And then we're done. I probably left too much room there, but it's okay. You guys know, you guys can fit it all on one page phone now. Your teeny tiny hand. Okay. All right. Geometric distributions, what's the shape every time? Right skewed. Center, there's a formula. This is what I was saying about keep, change, flip. That is 6. You want to make sure that you can find these sentences later. If many pairs of fair dice are rolled, Making sure to put that first in there again, because you're talking about geometric stuff. Spread, last thing. Okay, now I want you guys to type this in the calculator. I want to make sure that we get the same thing. You should get 5.477. If you wanted to keep change flip in your mind with a fraction, you could have taken the top number times it. Guys, are you paying attention? This is important and I'm writing a sentence. You're gonna ask me, where do I find the sentence later? And I really want to show you that it's right here. I don't know what's happening. Kind of a big spread, don't you think? You could go anywhere from 1 roll to 12 rolls before getting doubles typically. So I guess if you roll a lot of times and you don't get doubles, you shouldn't be surprised.